Hey, so now we're going to enter 5.3, which is a little bit on polynomial theory. This just ties together some of the ideas that we've seen in sections 5.1 and 5.2 about graphing. So in 5.2, we were talking about how we want to factor a polynomial because its roots tell us how to graph that polynomial. And it turns out that every polynomial can be factored into products of its roots in that way. The tough problem is, how do we factor that polynomial? So we're going to start with a quick example that will also detail something called polynomial division, which is an important technique. So we have this polynomial f of x equals x to the fourth minus 2x cubed minus 5x squared plus 6x. We want to factor it and graph it. So I guess to graph it, we need to factor it to find the roots. So maybe for a first step, we notice that we can pull out an x minus 2x squared minus 5x plus 6. And now we have a third degree polynomial. So that's not great. In this class, we don't know an algorithm for finding the roots. But thankfully, the problem actually gives us that 3 is a root. And so the cool thing is that we're given that 3 is a root. 3 is not a root of x. So therefore, 3 has to be a root of this guy. So therefore, since 3 is a root, we know we can factor. Since 3 is a root, we get that we can factor out that term x minus 3. Factor, we get f of x equals x. Since 3 is a root, we get to write x minus 3. And then there's some polynomial q of x that's multiplied to it, where degree of q of x is exactly 1 less than this cubic, so it's 2. In this video, we're going to talk about how to find this q of x. And so for that, we need to do polynomial division, which is really reminiscent of long division. So first we write our polynomial that we're dividing by on the outside. And we write our polynomial that we're dividing into on the inside. And it turns out that if 3 is a root of the polynomial, then it divides perfectly into this other polynomial. That is, there's no remainder left over. So we kind of do polynomial division in the exact same way that we do regular division, where first we want to get rid of this x cubed. So we're going to multiply x minus 3 by x squared, so that way we get x cubed minus 3x squared. We subtract. And so then these x cubes cancel out. And that leaves us with an x squared, and we bring down the tail, an x squared plus 5x minus 5x plus 6. All right, for the next thing, we again just take x squared and we match it. We take x minus 3 and we try to match it to this x squared. So we'll add an x on there, and then we get x squared minus 3x. We subtract. And that gets us minus 2x plus 6. And would you look at that, x minus 3 goes exactly into it by just multiplying by negative 2. We get 0. So there's no remainder at all. And so this is long division. And that tells us that q of x equals x squared plus x minus 2. And we can also check this. If we do x minus 3, x squared plus x minus 2, if we FOIL this all out, I'm going to do it kind of quickly. We'll get x cubed plus x squared minus 2x minus 3x squared minus 3x plus 6, which equals x cubed minus 2x squared minus 5x plus 6, which is exactly the polynomial that we were trying to get. So therefore, we get f of x equals x minus 3, and then the last one, which is x squared plus x minus 2. And now that we have a quadratic, we can just factor that quadratic. And if we do that, we'll see we get x minus 3. This is actually a pretty quick one using that diamond method. We get x plus 2, x minus 1. And now we can graph the polynomial, do a black axis. We're going to plug in the roots. We have a root at 0 from x, at 3 from x minus 3, at negative 2 from x plus 2, and then at 1 from the x minus 1. The degree is 4, and it has a positive coefficient, so that tells us that the end behavior is positive on both sides. And since the degree of each of these terms is 1, which is odd, at each root, we're going to pass through the root. So our graph looks something like that, W shape. So that's polynomial division, and we'll want to practice that more. So it'll be on our homeworks, and it also will focus on it in class and recitation. All right, and we're also going to conclude with the remainder theorem that says exactly what we've done. So if f of x is a polynomial, so we let f of x be a polynomial. That's saying we have some function that's a polynomial. Then we'll just say a is a root of f of x if and only if f of x equals x minus a q of x for some polynomial q of x with degree of q equaling the degree of f minus 1. So that's saying that we can literally factor out that if we have a root, then we can literally factor out x minus a. And then get a subsequent polynomial q of x where the degree of q is 1 less than f, which makes our problem a little bit easier for finding the roots of q because the degree of q is 1 less. And so we'll be interested now in finding roots of polynomials and then factoring them out using polynomial long division. So there we go. In the next video, we'll talk about the rational roots theorem, which will give us a technique to hopefully find some roots.